Hi, and welcome to this shop Miscellany. This time around I have a quick project, well I hope it's a quick project, where I make a new fence for my mag chuck over here on the surface grinder. This one fits back here, and I like the little detent where it allows debris and fluid to flow, but unfortunately out the sides, not down here, because this is almost in line with this. So this touches before this does. So when I make a new one, first of all, this is aluminum, which I don't think is good, because I want to grind this so that it's parallel with the direction of motion, so that I can set myself up for anything I line up on here to be exactly perpendicular to the wheel, or parallel to the wheels, depending on how you look at it. Perpendicular to the fence, which is perpendicular to the direction of motion. I'm going to use steel. I tried and used some abrasion resistant steel, but that was a total failure. So now I'm over here and I've got some 4142 pre-hardens, like RC Rockwell C27 hardness, and I think that should be good. And another thing I'm going to do is I'm only going to have, where you tighten this down, I'm going to relieve channels on either side of it, on all of these spots here, so that debris and fluid can just drain straight down. I don't know if that's a good idea or not, but it seems like it should be. So I still need to clean the back of this chuck off before I put this back, because you want it to line up nicely. So let's head over and see if we can remake this part, but in hardened steel. As for materials, here's the original in aluminum. It's not quite 3/8 inch thick. It's a little bit under that. So I found some 3/8 inch 4142. This is pre-hardened, supposedly, like I said earlier, Rockwell C27, and it's ground flat already. Now I did attempt to make it out of some abrasion resistant steel and grind on the surface grinder, but every time I ground down a section, the thing warped on me. So it actually ended up being worse off after grinding than when it started, which I'm sure I could have done better if I'd known how to do it adequately, but ended up a total failure. You can see here, this is what it looks like. It's some AR 400 steel. You can see even the wheel burned one spot here where it stuck, because it popped up and warped and stuck into the wheel, which is crazy. But this was a total failure, so hopefully I'll have better luck with this stuff, because this is already supposed to be flat. Hopefully they've heat treated it so that the stresses are out of it, because when I cut these grooves out of it, I don't want it popping up, but we'll see. Hopefully not. So over here on the bandsaw, to cut this, rather than put it the narrow side down where it'll cut the quickest, this blade is a pretty coarse blade, so I really don't want to have so few teeth engaged in the material, especially hardened material. So instead, we're going to do it vertically. It'll take longer because it's going to bite a big piece, but the blade will be much happier. Considering this RC27, it's cutting pretty darn quickly. All right, so we've got this guy mounted here on a bunch of these blocks of material made from tooling plate, aluminum tooling plate. I've mentioned it before. It makes really good spacers because it's accurate to better than 1/1000th. And this rod is like 10/1000ths out of flat. It's not flat at all, although it is parallel. The sides are parallel, but it's warped. So they didn't fix that. I did get this aligned with the ways here. So I've got the indicator, and it's about 1/2,000th over the length of the part here. I'm thinking about adding a third clamp here, because I'm just grabbing on the edge, which is not ideal, but I'm going to machine a slot here. I guess I could have one come from the other side, because I'm going to machine a slot here and then clear out all the material down here around where the slots are going to go. I brought this guy over so I could line up the clamps so they'd be where those slots are, because I'm going to leave like a 3/4 of an inch on either side of each one of these slots as free. So that's sort of the plan here. I think one more clamp. I'm not terribly comfortable with this clamping situation because I'm just grabbing on the edge, but it's probably good. You're probably wondering where my ring light is. There it is, hanging over there. That's because the ring light won't fit in place when I've got the indicator here. So can't have both at once. I got to figure that out, different solution. All right, so we got the ring light back up there. I added the extra clamp just on the edge there. And here's with the ring light. And you can see, don't really need this anymore. Or if I need to just hit a spot on something, that'll work too. Okay, next up, we got to find our dimensions. We got to find the edge and both sides here. All right, so I've got my Y0, so the top of this part. I want the slot, the 1/4 inch slot that's going to go down the length of this. I want that to be the edge of the cutter to be 1/4 inch down. Got a 3 flute 1/4 inch end mill in there, and I think we're gonna go 50 thousandths depth of cut. Try 1500 RPM. I decided for only 200 thousandths down, not 250. It just looked like too much. So interesting, when you have the quill down, gets in the way of the ring light. So I guess I do need my spot. Next up, we have to put 4 screw hole slots, which actually, come to think of it, I think these are going to be in the way of. Oh, actually, they might just clear. Maybe just because this is actually higher. Yeah, I think it'll actually be fine. So those aren't going to interfere. That's actually good. And so rather than measure off the edges, which are completely non-precise, I've still got to run the end mill over these edges just to clean them up a little bit. I went out of the center, so I measured the spacing between it. So 2.207 will be the first slot, and then 4.624. That looks like right on the money. Oh, you don't add half, you add the complete, that's why. So I've got to add 2.207 plus 4.833. That's what I did wrong. There we go. Second slot is 7. So let's do these first ones first. 2.207 over. And I'm going to try and plunge. I don't know how well that'll work, but we're going to try and plunge. This is a center cutting end mill. So I'm just going to lock the x-axis here. All right, next up, we're going to clear out this material. We're going to leave 3/4 inches from the center of material available on either side of this to support it when it's tightened down. It's going to be tightened from the back this direction, so this part meets up against the mag chuck. So I want a good supporting surface, but I want also a decent gullet for the material. And I'm not going to go quite as deep as this upper slot. I'm going to go only 120 thousandths deep. It's a bit fast for this end mill. Oh, well, that sucked. Yeah, too much force there. That's what you get only catching just the edge. And trying to take an 1/8 inch cut in hardened material. It was clean. It was doing a clean cut, but it's just too much force on the mediocre clamping scenario I had there. Okay, I've added much beefier clamping. And what I'm gonna do is just move the clamps when I need to do a section. All right, I'm gonna see if I can do 120 thousandths now. I've got a much bigger bite on this. All right, so that was a fail over here. As you can see, it cut into this top section even though it's supposed to be 5 thousandths floating above it. That's because I'm not using a Weldon flat end mill, and the end mill is obviously sucking out like they do. So I'm going to tighten the end mill in there more. I don't have a Weldon flat half inch, so we'll crank on it a little more, and we'll do the next section, try and do better. So we still got end mill suck on this side, even though we were more careful and took lighter bites, but it still pulled the end mill out a couple of thousandths. We were 5 thousandths above and ended up with the end mill cutting in a few thousandths into the base there, which means that it sucked down like 6-7 thousandths. If this was critical, then we'd have to use something like a Weldon flat, a different holder than we are using, than just to collet. But since it's not, this is just a drain for debris, it doesn't really matter. It just annoys me that it wasn't better. But we can certainly live with this. The important surface is right here where it mates up with the side of the mag chuck. All right, so we're done here. I'll be curious to see how much removing this material caused it to flex, because I think it's gonna. I just need to deburr it, and then we can go over to the surface grinder and put it on. And I'll still need to take the surface grinder once it's mounted and plunge cut through the whole edge here just ever so slightly so that I get it exactly parallel with the direction of motion. And then I can indicate off this in the future to reset up the mag chuck if I ever have to take it off. All right, here's the old fence and here's the new fence. See, it'll only hold in, you'll only put pressure in a couple spots, and this will allow material to drain out the back. I don't know if that's a good or bad thing. I guess we'll find out. I have more of this material. I could make another one and just put the slots in this relief here and be done with it. I just thought this might be a good idea. I didn't do a perfect job by any stretch. I had some depth issues with the end mill pulling out, which I've had with 1/2 inch before. They're just kind of large, especially with hard material where there's lots of forces. I was only taking about an 1/8 inch cut passes, but still enough to pull, so not great. But in any case, let's get this guy bolted in place and see what we have. Now that I got the new fence in and all the way up, it also goes down so that it's below the level, top level of the chuck here. I need to take a wheel, and I need to remove material up high here so that I'm only cutting with the bottom section of this. So I'm going to relieve the back side of the wheel that's in there right now, and just leave the bottom like 1/4 inch of material. And we'll make sure, first we'll dress that going all the way up, and then we'll go in, plunge in further and remove it up. That way it only cuts in a small section. Then what we're gonna do is just come across the whole thing and plunge down slowly and get a nice parallel surface with the direction of the chuck. You can see the area that's cleaning up there. Hard to see, I know, I'll bring it back. I used a 60 grit wheel, and I don't know if you can tell, but that is a freaking amazing finish on that. So the fence is now in line. It took a lot of passes because I was plunging down only a few thousandths each pass, and the interference was only a few thousandths, but I was trying to get a really good finish, and I think I succeeded. Anyways, there we go. I think we're done. And I'm very happy that I have a decent fence on here now instead of the aluminum piece of junk that I had before. All right, so next up we have a few new acquisitions in the shop. First one is a first surface mirror, and it came all the way from Ukraine during a war, no less, which I'm stunned that it got here. I purchased it early on, not paying close attention to where it was coming from, and it still made it here, and the packaging looks like it's going to be okay. It is really packaged well. They were careful. Holy cow, it is taped within an inch of its life, and it seems to have survived the trip quite nicely. They knew what they were doing when they packaged this. So I had an autocollumnator. I've had one for a while. I showed in one of my earlier videos, and I did not have a first surface mirror to aim it at. Now I do, and this one has a reticule to aim with. It was packaged with a bunch of paper and cosmoline stuff, like a lot of items from Russia are, which maybe is where this originated, I'm not sure. It was listed as in new shape, but stored on a shelf. Here's the first surface mirror with a protector. Oh, very good. It's a little bit of dirt on there. See if we can clean that off. With the first surface mirror, you got to be very careful because the part you're cleaning is the mirror itself. So yeah, you got to be very careful. I don't know if these are mounting shoes for something here. I'm not entirely certain. I must admit I am a little out of my depth on this particular topic. These things look like they're precision ground and adjustable in 3 points. So clearly you want to set these up so you can make them perfectly horizontal and vertical. At least that's what I'm reading here. All right, so I've cleaned this guy up a little bit. You can see the mirror's in really nice shape. There's just a little bit of schmoo around the outside, which I need to get some photo paper to clean off, because I don't want to damage it, because this surface is the reflective surface. It's not behind glass. That's what they mean by first surface mirror. Still got some cosmoline all around. And the sight comes out right out the middle, so it helps you line it up with your collimator. So it's pretty cool. I don't know what this does. This whole bottom part seems to be floating, but I don't really know what this does. Some sort of adjustment, but I can't tell exactly what. It doesn't feel like it does anything, so maybe I'll have to open this up and find out. I'm not entirely sure. I'm kind of curious about that. So maybe we'll save this guy for a future video, but at least it gives me a first surface reflective mirror for future videos where I use my collimator if I ever get around to it. I still need to learn more about how to use that appropriately. I hate making videos when I don't really understand it. I know that my channel is all about discovering how things work, but I like to have at least some idea before I talk about it, so I'd like to do a little bit of research. There's something moving in here. I don't really know what it is. I don't know what this Russian means, although if I had my phone, I could translate that, thanks to Google Translate. Let's see what that says. Huh, that means on, quite literally. That's all it says. So there is no explanation anywhere about how this thing works, and that's the only writing on it. So this one's on, and this is off. Maybe this is a mag chuck, I don't know. I'll have to try it. So I just tested this on a steel plate, and yes, this is a magnetic base. And this is a magnetic switch that's on, and that's off. It's kind of stuck inside, so even though it's in new shape, it'll take some work. But that's it for this one. Pretty nice piece. Got it for a couple $100 out of Ukraine. By the way, the guy who sold this to me, I'll see if I can find the link to his channel down below. He does absolutely amazingly accurate work with very simple tools. So you definitely want to check out his channel, especially if you like scraping, because he's an expert. Next up, we have another tool from Vevor to take a look at. They sent me to evaluate. And I believe this is an HVLP sprayer gun. Comes with a manual, nice. Spray handle, looks like valve, some Teflon tape, and the paint cup. So next up, just looking at the part quality, they seem to be quite good. Well, this valve is a really inexpensive valve, but probably functional. It looks like a needle valve type. By the way, just as I'm taking these parts out here, just so you know, HVLP means high volume, low pressure. And high volume, low pressure sprayers take advantage of the fact that the velocity of the paint particles is much lower than in a high pressure standard paint sprayer that you'd see around. So there are plenty of paint sprayers that you just attach to your compressor, put in 90, 100 psi, and that air pressure siphons paint up. You tend to have to thin house paints out, but very thin base paints, they spray very nicely. But because the air is coming out at a high velocity, especially since it's put through a tiny hole across a needle, what ends up happening is that the velocity of the paint is so high that most of the paint bounces off this whatever it is you're trying to paint. So the advantage of high volume, low pressure is that you use a lot of air at like 3 or 4 psi, maybe 8 psi kind of thing. And the advantage is that the particles of paint, the velocity is much slower, so more of the paint sticks on what you're trying to use. I've heard efficiencies of standard spray painting, like out of a spray paint can or air compressor based standard sprayer, being down in the like 20% or less range of the paint actually making it onto your material and staying there. HVLP promises higher efficiency. I don't remember what the efficiencies are off the top of my head, but it's a lot better Just looking at the quality of all these parts, they look really surprisingly good. The fit and finish is really nice, better than I expected going into this. However, there's a gotcha right off the bat. So normal HVLP paint sprayers use a turbine, a 4-stage or a 3-stage turbine to power the gun. And they have a very large diameter hose, usually around, I don't know, about 1 inch in diameter. I have one. And as a result, they can do high volume with the turbine. This requires 16 CFM at 90 PSI. I've got to say that this is beyond the range of almost all home compressors. Certainly all 110 compressors, and probably most 220 compressors as well, until you hit 3-phase. Or you hit like 50 amp circuits, because this is like on the edge of what a 5 horsepower could do constantly running with intermittent spraying. And I think you need like a minimum of 7.5 horsepower to make this thing really go. So that's just off the top of my head. So this puts it out of range of most people. It's only 108 bucks on Amazon right now, at least last one I checked. So the price is amazing, especially for the quality of the materials here. The feel is good. You can see the fit and finish is pretty darn good everywhere. It's got replaceable paint caps, and I forget what you call this part, the Venturi, I think. Maybe that's not quite right. And then the needle. So it should come with replaceable parts there, so you can exchange those out. And you change those based on the viscosity of the paint you're using. Now, another thing that's interesting is this is a gravity-fed paint cup. So this paint cup screws in right here. It's an interesting design. I kind of like that. However, most of the HVLP paint containers I've seen are actually sealed and have a low-pressure hose going to them to force the paint down into the gun. This one's relying on gravity. I wonder how well that works. I don't know what the answer to that is off the top of my head. So it comes with a set of tools, which is nice, some cleaning tools, and some removal tools here, which is just a press fit wrench, and a really interesting long Allen wrench there. Compressor fitting, which is nice, and some strainers, because another thing with HVLP and all sprayers is that you got to make sure that the paint does not have any gunk or particles in it, because if you do, you will clog the paint sprayer. So it comes with 1.3 and 1.7 millimeter tips. This one is for even higher viscosity paint. Probably house paint, if you thin it down, would probably work. But I gotta say, even though the quality of this all looks pretty reasonable, this is the cheesiest part of everything here. And this adapter right here, this is chrome plated plastic, but the rest of it, all metal and aluminum by the looks of it. The caps are brass and chrome plated, which is really nice with built-in gaskets. So the quality is excellent, but at 16 cubic feet a minute, I can't even use it. I have a 5 horsepower 240 compressor, but it's only a 125 PSI. You might be able to get away with a 5 horse that goes to 175 PSI with an 80-gallon tank. I only have a 25-gallon tank. This would just cycle nonstop. You wouldn't be able to continuously paint with this. So I can't really evaluate that. I can say that the machining quality and how clean the parts are, they deburred them, and all the sort of finishing things you don't always see in some of the Chinese tools, they did do here, and I'm pretty impressed with the quality. I can say that if you have the compressor and you need something cheap and inexpensive for just a couple quick projects, this might be worth the money, because it's really inexpensive considering how nice a quality everything seems to be. And that's about all I can offer to say about that. One more thing is I've temporarily put this back in the shipping box. If anyone out there, has a use for this, drop me a line and maybe we can connect, and I can get this guy to you, because it's certainly too much for anything I can use. Next up is some shop storage stuff for hanging stuff on the wall. This system promises to be able to hold 300-pound weight of hoses and cables and things you might hang on the wall, or I guess even tools in the shop. It's a similar system that they sell at the big box stores, except the price is only 29 bucks. So it's far more cost effective than what you'd get at Home Depot and Lowe's for the most part. They're a lot more expensive. In typical Vevor fashion, they included hardware to mount it to your walls, although I don't think I'd want to put this in drywall. I would think that I would want to find studs, so I doubt I'd use this, but it's nice that they include it so that if you wanted, you could set yourself up. This set comes with 3 rails. It looks like they come with a manual. All of them are reasonably well-written manuals, and it looks like they even have kits that you can buy individual pieces. I didn't see any of those, but the system looks pretty straightforward. And once it's up, it looks like it's just friction. So you can reposition these very easily. It's got these little plastic pits on the bottom, bumpers that snap in. I think after a while, I would think the ozone in the air would kind of deteriorate these. They may get loose, but they'll still be able to support the weight because all of the weight is carried by the metal part on the top here. So for 29 bucks, I think this is a pretty good deal and lets you organize a bunch of stuff if you need to in the shop. So it comes with 2 short and 4 long and 3 piece of track, all for 29 bucks. And I looked at a big box store, in my case Lowe's, and this is a really good deal compared to what I could find there. They had similar things, it's just a lot more expensive. Next up, they sent me this folding cart, also by Vevor. They make a model that goes up to 1,000 pounds. I don't think this is it. The 1,000-pound ones does horizontal and standard, like refrigerator dolly style. I'm not sure what this one does. It looks like this one is refrigerator only. They don't say what the weight capacity is on this, but looking at all these rivets and aluminum bits with what looks like plastic cross pieces, maybe they're aluminum. No, they're plastic. So all the plastic cross pieces, I'm thinking there's no chance this is 800 pound, the 800 pound version or 1,000 pound version. They did put aluminum where it matters the most. Let's see. So there's what they look like open. Okay. 220 or 264 pounds in normal use, and absolute limit 275 or 309 pounds. Very readable manual though. A lot of plastic though, so it was not designed for heavy duty work. Oh, I like that. So when the bottom folds out, the wheels pop out at the same time. So it folds very easily. Has some clips with bungees on it, so if you want to hold some parts down, that's also handy. And the top right here telescopes up to make it handy, and it looks like, yeah, these guys would flip to the side if you want to carry some stuff. So this is a tool made for carrying boxes and stuff out of your car. A couple 100 pounds, not super heavy, certainly not a refrigerator or anything like that. A lot of plastic. What I have here is a 80-pound, 8-inch Yuasa indexer and tailstock, brand new in the box. Stored in the store. I've been trying to get rid of it because it's too heavy for me to use on my mill, mostly too heavy for me to pick up. My back will go out. So I've been looking for a home for it, but I haven't been able to find one. This is one of the fixed indexers that has plates that stop at like every 15 degrees or every 90 degrees or every 60 degrees. Very accurate, but not as accurate as their super high-end model. Still very nicely made. Anyways, this is 80 pounds. It's on a dolly. And this guy carries it just fine. I got to tell you, everything flexes a lot, and this is only 80 pounds. So if you put 175 or 200 pounds on this, you're going to know it because it's going to flex a lot. This already is flexing a lot at 80 pounds, let alone the 240 or 275 that they say it can handle max, and 200 that it can handle, you know, on a daily basis. I don't know that I would do that. You could handle probably 50 pounds of boxes on a daily basis. I think the rest of this is going to kind of stress it a bit much because there's a lot of flex in this thing. Although flex can be good, you know, to prevent joints from failing because they flex instead of the joints taking it hard. But I don't know. Doesn't feel really great to me. I don't know that I would get this for anything heavy. Anyways, that's it. Thanks for watching. Hope you find it useful. Hope to see you next time.